Hello. In today's lecture, we continue from where we stopped last time, and we'll continue to look at Euclidean geometry. Euclidean geometry. And we'll continue where we left off. We're looking at translation, which translation is essentially a movement, form of transformation. And we had said that in order for a translation to take place, one, there must be a direction, and a displacement. So let us very quickly recap. If we have, say, that as our object, that triangle is our object, and this triangle is now transformed through a translation of two units in the right. If it's 2 units in the right, that means almost every other point is going to move 2 units. So let us say that's 1 unit and that's another unit. So this will have to also move 2 units. Therefore, it will move from there. If that was 1, 2, if that was A, B, C, point A will move to A prime. Point C will move to there, C prime. And point B now, it's got to be 2 units, will move to about there, B prime. If that was our T, this becomes our T prime. It's a displacement in the right direction, 2 units. So that is a translation. Now today we'll move on to a reflection. A reflection is also another rigid transformation. We talked about rigid transformation. Rigid because the image and the object will remain exactly the same in shape. In other words, the change is only either in the orientation or the position of the object, but its actual size remains the same. So it is a rigid transformation. So then let's look at reflection today. As the word goes, reflection means you begin to think of a mirror. When you are standing in front of a mirror, you would be somewhere there, and let us say there was a mirror here. You would see yourself looking somewhat like that. Now, with a reflection, there are 2 things that must happen. One, there must be a reflection line. A reflection line. And every unit on the object will move exactly the same number of units. Rather, every point on the object is going to move exactly the same number of units from the image and the object. That's our image. That's the object. So if this is 2 units from the mirror line, sometimes called the mirror line. If it is 2 units from the mirror line, that's A. A prime will also be exactly 2 units from there. If that is, the whole of that is B, it is going to be B prime will be exactly the same units. That will be the same units as that. So that becomes very, very critical. and it is perpendicular. Everything moves perpendicular to the mirror line, the same distance. So with the reflection, therefore, we talk about everything is equidistant to the line of to the mirror line. So equidistance in the sense that this is exactly the same as that. Now let us look at a Cartesian system and see how reflection will look like. Let's say we have our x-axis, 3, 4, 5. Again, always label. 2, 3, 4, 5. Always label. And in your case, you really need to use a ruler because accuracy is very critical when it comes to transformation. 4, 5 in the y-axis. Let's now say this is our triangle again. The triangle, the coordinates here, it's important. This would be 3, 1. That would be 2, 3. Always we need to label, remember the x coordinates are labeled first and then followed by the y coordinates. And this would be 1, 1. Now let us say now, this time, the reflection is along the y-axis. The reflection, so the y-axis therefore is our mirror line or the reflection line. What that means is that this triangle, every point on the triangle is going to move exactly an equal number of units on the other side of the mirror line. Remember, I gave an example of a mirror. When you are standing in front of it, the distance from yourself, your image, you are the object, to the mirror is exactly the same distance as the image that you see of yourself from that image to the mirror. So the mirror line becomes very important because that identifies whether the transformation is a reflection or not. So that distance, therefore, is critical. That distance there will be exactly the same. So 1, 1 will now move to negative. Let's label this again. -1, -2, -3, -4. 1, 1. If the y-axis is our mirror line, 1, 1 is going to move exactly the same number of units, which is 1 unit. So it will now be negative, because the x-axis is on the negative side, so it will be -1, but the y-axis is still on the positive side. So -1, 1. Now let's see the number of units that this point has. Let's label the points as, again, A, B, C. Our point C is how many units from the mirror line? We count from the mirror line or the reflection line. It's 1, 2, 3 units. So from the reflection line on the opposite direction, it is going to be 3 units because it's being reflected. So it will be 1, 2, 3. So it will be along on this line. Now it is 3, 1. So it will be -3, -3, -3, 1. There. Then let's look at point B, which is 2, 3. How many units is it from the mirror line? It is 2 units. 2 units. So it's going to move 2 units in the opposite direction on the opposite side of the mirror line. So it will be 1, 2. So it will be on the x-axis -2, 3. -2, 3. And we have already outlined the first one. So when we connect the image of T, and we get T prime. Now, the important points here always to remember, especially when you are teaching this, is that the distance from the object to the mirror line must always be the same as from the mirror line to the image, and must be perpendicular. So the angle that it makes here is perpendicular. Everything is perpendicular to the mirror line. So that will be the image of T after undergoing a reflection along the y-axis. Now let us now look at what happens to T if it is reflected on the x-axis this time. Let me probably give you a few minutes to think around that. What would be the image of T when reflected on the x-axis? Okay, have you thought around it? Good. Now, let us look at it together. Again, let's look at our mirror line. Our mirror line, we're asked to find the image of T when reflected along the x-axis. So the x-axis, therefore, the x-axis becomes our reflection line. So if that is the reflection line, that means every point on T, A, B, C, is going to move exactly the same number of units from there to in the opposite direction. Let's go back and just label this. This would have been B prime. That would have been, that was our A prime, and this was our C prime. Now let us, since it's the same triangle, therefore the image we're going to get, therefore, will now be T double prime. Okay, so let's start. It is reflected along the x-axis. So let's see what would be the coordinates of A. A is 1, 1. It will be in the opposite direction, so it will be there. Therefore, it should be negative, rather, in the x-axis, it's still 1, but in the y-axis is negative 1. So this will be 1, negative 1. That would be A. B will be here. That distance there should be the same as that there. So it will be 3, negative 1. 3, negative 1. That will be our B. Rather, our C. Our B, now let's look at the units. It's 1, 2, 3 on the x-axis, on the y-axis, so it will be on the other side, 3 units. 1, 2, 3. Again, let me label this. 1, 2, 3, 4. But this is negative side of the y-axis. So this will be the point. X-axis is still positive, but the y-axis is negative 3. There. Our image, therefore, will be, we connect that, and that. That gives us our T double prime. So that would be the image of T after it has undergone a reflection on the x-axis. A reflection along the x-axis. Now look, the distance of C to the reflection line is exactly the same as the distance of C prime from that point, the reflection line. The same applies to the distance of A, that to the reflection line is exactly the same as the distance of A double prime. So let me label these again mathematically. So this would be B double prime. This will be A double prime. And that will be C double prime. The reason being this, we're still talking about the same triangle. First of all, we reflected it on the y-axis and we got its image as T prime. Now the same triangle, we are now again reflecting it on the x-axis. That's why we are labeling its image now to be T double prime. So that's our final image is that, which is a reflection of T on the x-axis. Everything is exactly the same. So let's take a few more examples then. No, let me use the usual black. Now, when we are labeling lines on the x and y axis, 5, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, negative 1. Again, these units must be the same, please. Negative 2, negative 3, negative 1, negative 2, negative 3. This is positive 1. These are supposed to be the same. Yeah, so 1, 2, 3. Now, we have to remember, again, we label it y-axis. That's our x-axis. This will be in the negative. Again, it's still y, and that's in the negative x-axis. If we looked at this line here, if we drew a line along there, this is another line called, this line would be called x equal to 1. In fact, let's start with the x-axis. The x-axis is also called the line y equal to 0, and the y-axis is also called the line x equal to 0. The reason being, along the x-axis, the value of y will always remain 0, meaning that we have not moved anywhere up or down the y-axis. So the y-coordinate along the x-axis will always remain 0. That's why we call the x-axis is the line y equal to 0, and also the y-axis is the line x equal to 0, because everywhere along this line, the value of x will remain 0 because we have not moved anywhere in that direction at all. So it remains 0. Now, so sometimes, therefore, in mathematics, we can say, given a triangle, given the figure T, reflect it in the line x equal to 3. So this would be the line x equal to 3. Meaning, almost every coordinate on this line, the value of x coordinate will remain 3. If I picked up a point here, this is probably 3, negative 3. If I picked up a point there, this will remain 3, 1. If I picked up a point there, this would probably be 3, 4. So the value of the x coordinate remains 3. That's why this line is x equal to 3. Now, if I also picked up another line there like that, it passes through 2. Therefore, every value of y here, this is the same line equal to y equal to 2, because at every point that I pick up, the value of y will be 2. For instance, here, this point would be 6, 2. If I picked up that point would be 5, 2. If I picked up any point there, for instance, that would be negative 3, 2. So that's the line y equal to 2. If I drew it down here, this would be the line y equal to negative 2. If I drew that line there, that would be the line this is x now. X equal to, you can see it passes through 6. X equal to 6. So at every point, the value of x is 6. So in reflection, therefore, in transformation, we sometimes use these as either as mirror line or as transformation lines. And I thought you should take note of that. So let's look at a new transformation this time. Again, 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3. That would be negative 1, negative 2, negative 1, negative 2, negative 3, 1, 2, 3, 4, 5, 6. This is the x-axis. That is our y-axis. That would be 1, 2, 3. Now we're asked to maybe, we are given a rectangle like that. We're asked to reflect it in the line x, in the line reflect the rectangle in the line y equal to negative 1. Now, the line y equal to negative 1, therefore we go to negative 1 here, so this would be the line. And we're asked to reflect that rectangle in there. Let me give you maybe a few minutes to think around it. Now, that means that is the line y equal to negative 1 becomes our mirror line. That is therefore our mirror line, meaning every point there, A, B, C, D, is going to move exactly equal distance from there. Now the mirror line is that, so it will be in this opposite direction. Equal distance. Now look at D. D is 1 unit, so look at the units. It's 1, 2. So it's 2 units from the mirror line. It must also move 2 units. So this is 1. It will end up at there. That will be D prime. Like that. There. And what about A? Again, it's 2 units, so it will be 2 units from there. It will be, A would be here. Look at B. B is 1, 2, 3, 4 units. So it's got to be 4 units from there. So it will be 1, 2, we continue with our line. This would be 4, this would be 5. So it would be 1, 2, 3, 4. So our B would be there, and the next one would therefore be there. And that would be more or less, it's not more or less, it's exactly. So that's our A prime, B prime, C prime, and our D prime. A reflection of rectangle into R prime on the Y, on the line Y equal to -1. That is our mirror line, Y equal to -1. Now let's take a few examples then, rather exercises. Okay. Again, let's label. Our first, we are given these are the coordinates. This is negative side of the x-axis, and that's the, oh dear, what have I done? Sorry about that. That's our y-axis. And that's the negative side. So then, we are asked, these are our coordinates. I think it's better I label them for you. This would be -4, 1. That is -2, 1. And that is -3, 4. 1. Reflect T along line y equal to 1, 2, x equal to 2, 3, x-axis, 4, y-axis. Transform T 2 units. To the left. Transform to T 2 units to the left. That's, let me quickly. Right. So you have 2 questions. One, reflect it along along these lines. Y equal to 1, x equal to 2, 3 x-axis, y-axis. And then the next one is you are requested to transform T along, transform T 2 units to the left. Okay? Thank you very much.